Today we're going to talk about indeterminate powers. There are three types of indeterminate powers. We're going to talk about the strategy to deal with that and also relate that to the L'Hopital's rule. Indeterminate powers. There are three types of indeterminate powers that we're going to talk about. They are 0 to the 0 power, infinity to the 0 power, and 1 to the infinity powers. The strategy to deal with indeterminate powers is to take Ln so that we bring down this exponent. Okay. I'm going to give one example for each type of indeterminate powers. The first type here is 0 to the 0 power. This one here is 0 to the 0 power. The base go to 0. The exponent also go to 0. Okay. Now, we're going to take the limit of this function that you have the x in the exponent, okay, and also x in the base. So we need to bring down this power. The function you can bring down the power is Ln, okay. So we're going to let a to be this function, x to the x. Then we're going to take Ln. Ln of a is going to be Ln of x to the x power. When we take this Ln of x to the x power, this exponent here is going to drop to the front of this Ln, and it's going to give us x times Ln of x. Now, instead of taking the limit of this x to the x, we're going to take the limit of Ln of x to the x, which is Ln of a. Okay. Because a and Ln of a are related, if I can somehow find the limit of Ln of a, I can go back to find the limit of a right here. Okay. So take the limit of Ln of a. So that's the limit of x times Ln of x over here. Now we want to see what type is this limit right here. We see that the x over here goes to 0. Ln of x as x approaching 0 from the right side is going to be negative infinity. This x here, it goes to 0. And Ln of x is going to go to negative infinity. So this is the type 0 times infinity. Remember, 0 times infinity, this type also includes 0 times negative infinity. Remember, this is an indeterminate product. You cannot rush to the hospital yet. We need to apply some CPR before we apply L'Hopital's rule. Okay. So what we do over here is we're going to do some CPR. Now, do you remember what kind of CPR we do? Well, for indeterminate product, 0 times infinity, we're going to keep one of the function on top and then divide by the reciprocal of the other function, right? So that's how we deal with this indeterminate product, okay? So let's think about which one that we keep to the top, okay? So we want to keep the complicated function on top. So that was a strategy that we mentioned before, okay? So out of these two functions, Ln of x is more complicated, and we want to keep this Ln of x to the numerator. And now we're going to divide by the reciprocal of x. Now let's see what type is this limit right here. Ln of x is going to go to negative infinity. 1 over x is going to go to positive infinity, and we call this the type infinity over infinity type. Now, as you notice that this infinity over infinity type is one of the two emergency type that you apply L'Hopital's rule directly. We'll apply L'Hopital's rule, so we rush to the hospital. Apply L'Hopital's rule, we're going to differentiate the numerator and the denominator separately. So the duality of this Ln of x, as you recall, it is 1 over x. And the duality of 1 over x is negative 1 over x squared. Now we want to simplify it. When possible, always simplify the function that you're taking limit with first, before you apply L'Hopital rule. Okay. So to simplify this, you can either multiply the numerator and denominator here by x squared, or you think about dividing by this is the same as times the reciprocal of this. In any case, this is going to end up to be negative x over here. Okay. When x approaching 0, negative x is going to approach 0. So this limit here is going to be 0. Now, this is not the final answer here yet, because this is the limit of Ln of a. Well, we're trying to define the limit of this a over here. This quantity here, we call that a. So we try to find the limit of this a over here instead of the limit of Ln of a. So we found this limit of Ln of a, which is 0 over here. Now we're going to relate this with the limit of a. First, you notice that a is equal to e to the Ln of a. Remember, this exponential function with base e and the log function with base e, those are inverse function, and they'll cancel and get back to this a right here, right? When the base here and base here are the same, you get back this a over here. So we can replace this a over here by e to the Ln of a. So because e to the u, think about this Ln of a here as u, e to the u is a continuous function in u. When it's a continuous function, then you can bring the limit in. So limit of a continuous function is the function of that limit, okay? So you can bring this limit in here. So this is going to become e to the limit of this Ln of a. That will become e to this limit. So e to the limit of this Ln of a over here. Now we just found that the limit of this Ln of a is 0. So this part here will become 0. So we got e to the 0 power. E to the 0 power, it is 1. And this is the final answer here. Now we are done. Okay. Now let's take a break.